Okay, and we're recording. So today we're going to go over a slightly tricky trig integral problem that a student shared with me. And just taking a quick look at it, we have a situation where we're integrating k sine of kx minus pi dx, where y and k are independent of x. It's going from 0 to y. And y is given by the solution to the equation cosine of ky is equal to some number. Doesn't really matter too much as long as it's between 1 and -1, but for the sake of just changing things up, I changed it to 1/2. So yeah, what makes this problem just seem a little bit tricky? Well, just looking at it, we're given that cosine of ky is equal to some value, right? Cosine of ky is equal to 1/2, but we know that cosine can map different values to the same value of 1/2, which means that we really don't know what k and y really even are, right? It could be, right, cosine is has a phase of 2 pi, so there's really infinite solutions to ky. And what's more, what makes it even nastier is that this k is kind of floating by itself, right? So not only do we not know what ky is, k by itself is even a bit nastier. But let's take a leap of faith and go ahead and do the integration, right? So the integral of sine is going to be, we'll write it down here, minus cosine of kx minus pi. And notice that the k and this k cancel out on account of a chain rule, right? When you integrate by something, you have to take into account chain rule. And because we're integrating, we're dividing by k. We're dividing by k. So this is going to be from 0 to y. And, well, let's look a little bit better, right? We got rid of that nasty little k. Now let's go ahead and plug this in. So this looks like minus cosine of ky minus pi. I guess it's going to be minus minus. So it's going to be plus cosine of minus pi. I'll let you take care of this part on your own, calculate it out. Double check my calculations, don't rely on me. I'm just here to show you the big ideas. But I want to just draw your attention to what's going on here with the ky minus pi, right? It's starting to look like something we can kind of get a grasp over. We're seeing cosine of ky, which is similar to this. It's just being subtracted by some value pi. And I just want to draw your attention to a trigonometric fact where if you have any, let's call it some arbitrary variable, not a variable, arbitrary angle z, right? The cosine of theta is basically represented by the length of its shadow on the x-axis. And the idea is if you subtract out pi, right? If you subtract out pi, this turns into z minus pi. It's the basic idea is subtracting by pi means a reflection across the origin, or a swivel of 180 degrees, right? So the point that I'm trying to make here is that the length of this shadow is exactly the length of this shadow just by symmetry, which means that because, you know, the sort of x component is sort of your cosine, this means that the cosine of z minus pi is exactly equal to the negative of cosine of z. So now instead of using z, we're talking about a ky, but you can still use that exact fact that because you know that cosine of ky is equal to 1/2, use the fact that generally speaking, the cosine of, let's call it z minus pi, is equal to minus cosine of z. So use this little trigonometric identity to hopefully solve the rest of the problem for yourself. Yeah, and I think that should hopefully be a good place to call it right there.